This exercise is exactly like the one that we did previously, the example number 1, but we just want to calculate the bending moment, okay, the nominal moment here. The section is the same, so we have 20 by 12, 4 bars of number 8 on the bottom, which is tension reinforcement, and on the compression reinforcement, we are going to have 3 bars number 8, okay? The distance D is 17.5, and this D prime, which is the distance from the compression face of the beam to the center of mass of the compressive reinforcement is 2.5 inches, okay? So the first step is to calculate the steel areas. Let me put this here, and let me also add our calculator here on the side. All right, good, good, good. Okay, so we saw that the area of 1 bar, 1 number 8 bar, the area is around 0.785, okay, square inches. So the tension reinforcement equals to 4 number 8 bars, and tension reinforcement is 3 times this value. Using the calculator here, 4 times 0.78, 3.2. So we have 3.2 inches, square inches, and then 3 times 0.785, 2.355. Okay, square inches. Good. And also, as we are dealing with 4,000 psi concrete and 60 psi grade steel, the components alpha 1, and beta 1, they are equal to 0.85, as we have seen previously. Okay, so the first thing that we assume is we assume that the tension reinforcement is yielding, all right, because we're assuming ductility. Okay, Yuri, but what happens if I select a specific reinforcement for the section and it's not ductile? Then you have to change the variables, which are the section depth or the number of reinforcements. Okay, you have to change one another because we always want to have ductile sections. Okay, so the second step, the third here, is actually selecting C. Okay, so we are going to select a position of neutral line that is either between d over 4 or d over 3. Okay, if you calculate, is either between 4.375 inches or 5.83 inches. Okay, if you well remember from the previous exercise, the position of the neutral line was around 4.4 or something. So I know for a hand that that should be lower than this, because as I said, whenever we put AS prime, we decrease the position of the neutral line. But as a beginning of the result, I'm going to put between 0.43 and 5.8. I'm going to use the first one, 4.5 inches. All right. And after the step 3, this is where the interactive process actually begins. Okay. So we select a specific position of the neutral line. I have put here on your right practice. All right. These practices are supposed to do another try. Okay. So we're going to do with all the calculations 4.5. And after we've done all these calculations, we will see that there is no equilibrium. And then we're going to reduce this. And then the new values I'm going to input here because it's going to be easier to do the exercise this way. Okay. You can use an Excel spreadsheet to do this. I'm going to show you at the end of this example. So you guys can see that's actually quite simple. So let's do the first interaction. Okay. The second thing to do after you select C is to find the strain, the compressive strain. So this is the equation. It's simple to determine this because of that. It's right here. Now we know that here is the compressive strain of steel, and on the top we have the compressive strain of concrete. We know that this distance here is dy, d prime, and this distance here is c. Okay, so obviously this here is c minus d line. So by triangles similarity, we know that ECU is 4C, okay? And then also is prime S is for C minus D line, right? So you just multiply this and you're gonna get this equation, all right? So the first result, I'm going to just put in red everything that we're going to recalculate, so it's going to be easier to track. Okay, so let's do the first calculation here. We have 4.5 minus 2.5 divided by 4.5, and this multiplied by 0.003. Right, first result, 0.00133. Okay, this is the first result. Whenever we change this, I'm just going to change the one in the practice. Okay, let's move on to the next step. So once we know the strength of the compressive reinforcement, let's calculate its stress. Using this equation here, just multiply the modulus of elasticity by the strain. So it's 20,000 psi multiplied by 0.00133. Multiply by 20,000. So this is around 38.66 psi. Okay, this value has to be lower than 60 because that's the strain of our steel. So it has to be lower. If you get a value above 60, just get 60. Okay. And then once we have the stress in the compressive reinforcement, let's calculate the section forces. So the first section force is the section force from the steel. As we said, you just have to subtract the force related to the concrete. So we got the value 38.66. Let's just subtract. Minus 0.85 multiplied by 4, which is the concrete 4,000 psi. All right, and this multiplied by the top compressive reinforcement area, 2.355. Now we have here the value of 83.053 kips. Okay, it's in kips because this cross-section area is in square inches, and this guy's here is in psi, which is kip per square inches. So cut, result should be in kip. And now let's calculate the force from compressive concrete. So just don't forget to put the value that we establish. Calculating here, 0.85 times 4 times 12 times 0.85 times 4.5. Okay, 156 kips. And lastly, the force of the tension reinforcement. The area of steel, I don't remember, I think it's 3.12. Okay. 3. Oops, I have to put this in black because we're not changing. 3.12 times 60. This one will not change. As well, this guy is in square inches, this guy is in psi, result will be in kip. 3.12 times 60, 187, 187.2 kip. As you can see, if you add this guy and this guy, that will go above 187, that's for sure. But let's just show here, guys. Here is 83.053 plus 156.06. Now let's add 83.053 plus 156.06. As I said, 239.13 cube. Okay, so as you can see here, has the equilibrium been reached? Check equilibrium. So as we can see, 239 is bigger than 188, which means the 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 depth of the neutral x it's quite big. So whenever we have this option here, we actually have to decrease the volume of C. As I said before, like for the simply reinforced concrete beam, it was 4.4, and we tried 4.5, which we knew it would be different. Okay. So for the next value, the next try, let's pick something smaller than 4.4, 4.5, sorry. I'm going to choose 4, okay, inches. And now all the values that I have calculated, I'm just going to put inside the practice, all right, in purple. So this is going to be easier. And now I'll go back to the step 3. I'll go back to step 3, which is right here. And now I'm going to fill these gaps here. So the next value of C is going to be 4 inches. And then let's just substitute everything that is in red. We just redo the calculations considering this new value of 4. All right, so let's calculate the strain and compressor reinforcement. So 4 minus 2.5 divided by 4.5. And this times 0.003. Okay, did I do this right? 4.4 minus 2.5 divided by 4. Now times 0.003. All right. The next value is 0.001125. Of course, has to be smaller because we're selecting a smaller value of C. All right. Let's jump to the next one. Now this value we change into the red, this guy here, and then we have the new value. So this one multiplied by 29,000. This is 32.025. Okay, as you can see, we're decreasing the values because we are re-equilibrating the forces. And now I upload it in here, and then I recalculate. So the process is quite simple when you have this exercise organized. So I'm just going to subtract 0.85 times 4, which is going to give me this part here, and then I will multiply by 2.355. Multiply by 2.355. So now we have 68.824. Got it. Now let's calculate this part here with 4. So the concrete contribution, 4 multiply 12 multiply by 0.85 multiply by 4, 138. The tension reinforcement does not change, okay? So now we have, it's a little bit bigger than 188 still. Let's see how much it was. Plus 68.824. So now we have here 207.5. Yuri, how many interactions should I go? Usually it's around 2 to 3 interactions. We're getting very close. We need to get the next value, which will still need to decrease, okay, because we did not reach convergency. So just select the next one. I'll just select 3.7, okay? Let's do 3.7. And whatever you guys do is, whenever this force here is very close, not necessarily equal, but around 2%, let's just call it 2% difference, that should be enough. All right, if you have 2% error, that should be enough. That won't change at all the moment strength of the section. So let's do the third and last interaction. I know the answer is 3.72. I will talk to you guys in a moment about this, but I'm just gonna check 3.7 so you guys can see. The last one, 3.7. Let's do here. 3.7 inches. Now let's change everything in the red again. So 3.7 minus 2.5 divided by 3.7. This multiplied by 0.003. Oh, okay. That's 0.0000972. Okay, 1, 2, 3, 4. Okay, got it. Well, very, very low. Let's go to the stress. Now this value multiply by 29,000. So multiply by 20,000, 29,000. So 28.216. Got it. And now let's go to this part here. Subtract. So minus 0.85 times 4. And then multiply 2.355. Right, we have 58.44. Perfect. And lastly, this last guy here. So 0.85 times 4 times 12 times 0.85 times 3.7, 128. All right. And now if we add them together, the next result that we're going to get, I put this wrong, it's in here is 3.7 inches. All right, now if we add them together, we have 58.44 plus 128. It's going to give us very close to the value that we're looking for. 316. All right, 186. Perfect. This is 186.75 kip. Okay. So as you can see here, it's very similar. Okay. If we would try to reach the perfect score, we would have in this situation to increase just a little bit, very, very little. I would increase to 3.75. That would be my next trial. Okay. But there is no need because as you can see here, it's so close, it's lower than 2%. So if I collect this value and I subtract to 188.4, and then I divide it by 188.4 again, I will have an error lower than 1%. Okay, so that would be perfect, right? So we know that our the value of C now it's 3.7 inches. Okay, I will stop this exercise here so the video will not be huge, and I'll calculate the moment capacity and other things in the next slide.